Good morning. I am Suni, Assistant Professor, Department of Mathematics, Rohini College of Engineering and Technology. Now I am going to teach the topic Laurents Series, the course MA 8251 Engineering Mathematics 2. The course outcome is after completing the course, the students able to express a function as a Laurents series. The definition of Laurents series is if C1 and C2 are two concentric circles with the center at z equal to a and radii r1 and r2 where r1 less than r2, and we consider the function f of z which is analytic inside on the circles and within the annulus between C1 and C2, then for any z in the annulus we have f of z equal to summation n equal to 0 to infinity a n z minus a the whole power n plus summation n equal to 1 to infinity b n z minus a the whole power minus n, where a n equal to 1 by 2 pi I integral over c1 f of z by z minus a the whole power n plus 1 dz, and b n equal to 1 by 2 pi I integral over c2 f of z divided by z minus a the whole power 1 minus n dz, and the integration being taken in positive direction. This series is known as the Laurents series of f of z about the point z equal to e. Now, the working rule to expand f of z as a Laurents series. Suppose we consider the function f of z as 1 by z plus a plus 1 by z plus b where a less than b. Now, we consider the region modulus of z less than a. So, in this always our region should be less than. Now, here the less than term is taken to the left side, it becomes the denominator, and the right side be 1. So, it is nothing but modulus of z by a less than 1. Now, the denominator we have a, so we take the constant term outside from f of z. So, from f of z in the denominator we take the constants a and b outside. So, if we take outside a outside, the denominator becomes z by a plus 1, that is 1 plus z by a, and the second if we take constant b outside it becomes 1 plus z by b. Now, we take the term 1 plus z by a and 1 by z plus b to the numerator, it goes power minus 1. Now, we apply the binomial expansion to express as a Laurents series. Modulus of z less than a, always modulus of z greater than a, always the region should be less than. So, for that we write it as a less than mod z, a less than mod z, and take this mod z to the left side, we get a by mod z less than 1, that means that we take z outside from f of z. So, for in f of z we take z outside in the denominator. So, we get f of z as 1 by z into 1 plus a by z plus 1 by z into 1 plus b by z. Now, take the terms 1 plus a by z and 1 plus b by z to the numerator, it goes the power minus 1. Again, we apply the binomial expansion. To expand f of z in the region a less than mod z less than b means we split the region as a less than mod z and mod z less than b. So, for a and mod z relation, we take this z outside. So, from the relation of a and z, we take z outside, and for the next relation modulus of z less than b, we take the constant b outside. So, for the relation z and b, we take b outside. So, our f of z becomes 1 by z into 1 plus a by z plus 1 by b into 1 plus z by b. Now, we take this 1 plus a by z and 1 plus z by b to the numerator, it goes the power minus 1. Now, we apply the binomial expansion. Now, we see some examples. Find the Laurents series which represents the function z by z plus 1 into z plus 2 in the region modulus of z less than 1 and 1 less than mod z less than 2 and mod z greater than 2. So, first we have to express the function z by z plus 1 into z plus 2 as we have to split it is in the using partial fraction technique, we split that is a by z plus 1 plus b by z plus 2. Now take the LCM. The right hand side LCM is z plus 1 into z plus 2. Now cross multiply, we get a into z plus 2 plus b into z plus 1. Now cancel the denominator, we get z equal to a into z plus 2 plus b into z plus 1. In the next step, we want to find out the values of the constants a and b. For that, we set the values of z that makes any one of the value, any one term as 0. If we give z as minus 2 means the value first term 0, and if we give z as minus 1 means the second term value 0. Okay, so we set z value as minus 2 first. So the left side becomes minus 2 and the right side we get only this term b into minus 2 plus 1, that is minus 1. Now minus minus cancel, we get value of b as 2. Now we give z value as minus 1. So the left side is minus 1 and the right side is a into minus 1 plus 2, that is 1. The second term is 0. Now we get the value of a as minus 1. Now after getting the value of a and b, we give this to our f of z. So our f of z becomes minus 1 divided by z plus 1 plus 2 divided by z plus 2. Now we consider the first region, modulus of z less than 1. We always check whether the relation is less than or not. We always apply the Laurents series in the less than region. So here is less than. So we take this constant term to the denominator. So it is modulus of z by 1 less than 1. So from this we take the constant term outside. From both the two terms we take the constant outside. So here the constant is 1. So not necessary to take it outside. For the second term, the constant is 2. So if we take 2 outside, the second term denominator becomes 1 plus z by 2. Now we take this 1 plus z to the numerator. It goes in the form of 1 plus z the whole power minus 1. For second term, 2 cancel. Now take this term to the numerator. It goes in the form of 1 plus z by 2 the whole power minus 1. Now we apply the binomial expansion for 1 plus z the whole power minus 1. It is nothing but minus of 1 minus z plus z square minus etc. For the second term, it becomes 1 minus z by 2 plus z by 2 the whole square minus etc. We have to write it as minus 1 into summation n equal to 0 to infinity minus 1 the whole power n z power n plus summation n equal to 0 to infinity minus 1 the whole power n into z by 2 the whole power n. Now consider the next region, 1 less than mod z less than 2. In this region we split it into 2, that is 1 less than mod z and mod z less than 2. So 1 less than mod z relation we take z outside. So 1 and z relation we take z outside, and mod z and 2 relation we take this 2 outside. So we take 2 outside. So we get it as 1 plus z by 2. Now take to the numerator, the first term becomes minus 1 by z into 1 plus 1 by z the whole power minus 1. For the second term it becomes 1 plus z by 2 the whole power minus 1. Now apply the binomial expansion for this. We get 1 minus 1 by z plus 1 by z the whole square minus etc. For the second term it becomes 1 minus z by 2 plus z by 2 the whole square minus etc. We may write this also minus 1 by z into summation n equal to 0 to infinity minus 1 the whole power n 1 by z the whole power n plus summation n equal to 0 to infinity minus 1 the whole power n z by 2 the whole power n. Now consider the next region, modulus of z greater than 2. We always take the relation less than, so it may be we write it as 2 less than mod z. So in the relation 2 less than mod z, we take z term outside for both the two terms. So for the two terms we take z outside, we get the first term value as minus 1 by z into 1 plus 1 by z, and the second term we take z outside means second term becomes 2 by z into 1 plus 2 by z. Now take this term 1 plus 1 by z and 1 plus 2 by z to the numerator, it goes the power minus 1. Now apply the binomial expansion. The expansion is 1 minus 1 by z plus 1 by z the whole square minus etc. For the second term the expansion is 1 minus 2 by z plus 2 by z the whole square minus etc. It may be also written as minus 1 by z into summation n equal to 0 to infinity minus 1 the whole power n 1 by z the whole power n plus 2 by z into summation n equal to 0 to infinity minus 1 the whole power n into 2 by z the whole power n. In this way, we have to express the function as a Laurents series. Now, some important questions in these topics are. Thank you.